Hey guys, 6.3a, solving systems, our third and final method. It's by elimination. Today, it's good. 6.3 is broken into two parts. This lesson's only with adding and subtracting, which will lead us into the next part. So our objective is to solve systems using elimination by adding and subtracting. To solve a system of linear equations by elimination, our goal is to eliminate one of the variables. We add or subtract the two equations together. And if we do it properly, which we will, we will be able to cancel out or eliminate one of the variables. So take a second, take a look at the list of the numbers. Which ones of these, when we add, would cancel each other out? And select all that apply. All right, so hopefully you recognize opposite numbers when you add them will cancel each other out. -1, +1. Add them together, you get 0, cancels out. All right, that's going to be the objective with solving systems using elimination, canceling out the same, well, I guess opposite values. Okay, so here's a system. Okay, this is, I'm going to use this as the example. X minus 2y equals -19, 5x plus 2y equals 1. Recall, an equation stays balanced if you add the same value, the same thing, to both sides. All right, if you do the same thing to both sides. So if 5x plus 2y equals 1, and we can add 5x plus 2y to one side, and I can add 1 to the other, because this equal sign says this and this are equal to each other. If they're equal to each other, even though they look very different, but if I add 1 to the right side, 5x plus 2y to the left side, it will stay balanced. It will be maintained. So in doing that, watch what happens. All right, when I add the 2x, sorry, we're gonna get my pen, I'm sorry, when I combine these equations, when I add each piece of it, all right, the 2y and the -2y, they have opposite coefficients. They are canceled out. And I'm left with 6x equals, this is a plus sign, -18. With substitution, it was a big, long process to get rid of one of those variables. We had to isolate and solve and substitute. But here, if we can identify when they're opposite coefficients, it won't always be that way, but today it might be. We can just add or subtract the equations together, whatever will cancel out those values, and we've done it. So now I have 6x equals -18. I can just divide by 6, and I have my x value to be -3. I have half of my solution just like that. Now the second part, all I'm going to do now is just like the substitution process. Since x does equal -3, I'm going to plug -3 in for x into one of my equations. I can plug it in there, or I can plug it in there. It looks like the top one would be easier to plug it in and then figure out what y is. I'm not going to go through that process now, but you would plug it in, then isolate y. Here are the steps, just like the word for substitution. All right. Again, I'm going to kind of go through this semi-quickly, but you may pause it, write it down as you please. Step 1 is you want to have your equations lined up with the terms, pretty much standard form. You want your x's together, then your y's, and then your constants. All right. Your goal is to then eliminate one of the variables by adding or subtracting. What you will then do is substitute that value, whatever you solve for, plug it into the other equation. Then you have your two ordered pairs. I know it sounds short, sweet, to the point. That's pretty much what it is. The last step is write it as an ordered pair and check. So here's another example. Let's solve this by elimination. To do this by elimination, I want to identify, are there any terms that I can cancel out? Well, my x's, nope, they're different. I have a 3x and a 1x. What about my y's? I have a -4y and a +4y. Oh, if I add these two together, they cancel out. But now I'm just going to add everything else. That's going to give me 3x plus x gives me 4x equals 8. Because 10 plus -2 is 8. I almost said 12. It's not. I'm then going to divide by 4, and I get x to be 2. Now that I have x to be 2, I have part of my solution. I'm now going to plug x to 2 into either one of the equations. I'm going to choose the one without distributing. So instead of x, I'm going to write 2 plus 4y equals negative 2. And now I'm just going to go through and solve my equation, and I'm left with 4y equals negative 4, divide by 4, and divide by 4, and I get y to be negative 1. So my solution here is 2, negative 1. This is a little bit shorter than the substitution method. It doesn't always line up and work out, but when it does, you want to pounce on it. Sometimes, if the equations contain the same term, not opposite terms, the last one, we had a positive 4 and a negative 4y. If they have the same term, to cancel them out, we need to subtract the equations from each other. And then it's the same exact process. So here I go. My x's, oh no, they're not opposite, they're not the same. My 4y's, I have a positive and a positive. The way to cancel out two of the same thing, whether they're both plus or both minus, is subtract it. 4y minus 4y cancels out. I'm also going to subtract here and subtract here. Notice I'm putting that subtraction sign each spot. I want to be careful with negatives. 3x minus negative 2, that pretty much becomes 3 plus 2 gives me 5x equals 18 minus 8 gives me 10. 5x equals 10. Divide by 5, divide by 5. X equals 2. I have half of my solution, which is 2 comma blank. Now the second half, this part takes a little bit longer. Both of these equations don't seem too crazy, but I'm going to do the top one because there's no negatives. What I mean by that is I'm going to rewrite the top equation, 3x, but instead of x, I'm going to plug in my x value that I just solved for of 2, and I still need to figure out what my y is, so there's still going to be a y in the equation, in my green equation here. So I get 6 plus 4y equals 18, take away 6, take away 6, I get 4y's equal 12. Divide by 4, divide by 4, y equals 3. So my x equals 2, my y equals 3, my final solution will be 2 comma 3. So this is very similar to when you add, you just got to be careful that you're subtracting. You must do the same exact sign, whether it's always adding or always subtracting. You can't mix and match, okay? And that takes care of the start of solving systems by elimination. Your work is combining equations, Khan Academy, a quizzes assignment. Again, you get 2 chances, and then your mastery check.